Hello friends and my dear students. In the next series of computer graphics, I'm going to explaining the geometric transformation second operation that is known as a 2D scaling. So I have already told about the transformation. What is transformation in my previous video, that is called translation video. So in that video I have explained the introduction part and as well as the first operation that is known as a transformation, that is translation operation. So total five operations are there, geometric transformations are there, in which the three basic transformations are translation, scaling and rotation. So in the second operation I am going to explaining that. So my dear friends, listen that video at the last so that you can understand very well what is scaling is there and what is the basic operation of scaling, what is the basic matrix are there, and how to solve the problems if any kind of specific problem is going to be occur in a scaling. So all everything or all about the scaling is explaining in this particular video. So at the last you can understand very well that what is scaling is there. So now going to start that particular second operation, that is scaling. So first of all, the definition is very simple, is that you can see that 2D scaling is a geometric transformation to alter the size of the object, either increase or decrease. Means scaling can be possible in an larger size or smaller size, means upscaling or downscaling by a scaling factor that is known as a sx in x direction and sy in y direction. Because we are studying or we are understanding the concept of 2D geometric transformation. So in that 2D translation 2D scaling is there. So in case of 2D scaling, so only two dimensions are there, x and y directions. So for x direction, the scaling factor will be represented by sx, and the the scaling factor is represented by sy in the y direction. So if you are going to understand that how the scaling will be represent, so the important is scaling is represented by multiplication. So scaling is always done by multiplications of any vertices value with the scaling factor. So x dash means new position will be get by using this multiplication approach. In the previous one I have told you about that translation. So translation is basically based on the addition. So addition of translation factor to the vertices get the new positions, but here is a multiplication. Then how this equation, means whatever the equation is right here, and how this equation will be right in a two dimension, means 2D 2 into 2 matrix. This is the matrix is there, and if you are going to be write this whole thing in a 3 by 3 matrix, so this is the 3 by 3 matrix, and this 3 by 3 matrix is basically used for next approach. Means if we are going to, I have already told about the previous video, means if you are going to apply the multiple number of or multiple sequence of transformations, so you need a 3 by 3 matrix. So this is the main matrix is there, so you have to be memorize this matrix for the scaling operations. So sx 0 0 0, sy 0 and 0 0 1. So this is the matrix you have to be remember about them. Now come to the point. Next one is called problems. If I have a problem, then how to solve the problem? Very basic problems are given here. You can apply this problem, means you can apply this matrix multiplication to the point. Already explain this similar type of operation in the translation, so you can implement or refer that operation in here, and you can apply that multiplication to get the points. So the question is that scale the polygon with the coordinate a25, b 710, c 10 by 2 units x direction, 2 units y. So 2 units means 2 and 2 values are there, so scaling factors are 2, sx is equal to 2 and sy is equal to 2. So this is 2 and this is 2 again. So this 2 is here, you can see that this is the 2 factor, this is the 2 factor, and this is a complete scaling. So this is called a scaling matrix, scale matrix. So 3 by 3 scaling matrix are there. And now come to the one point here. This formula is going to be actually used for multiplication. So here you can see that for one point it is showing here x, y and 1. So I have already told you about that. The representation of this particular point is x, y and 1. So this is the first one. You can see that this is a, so a value is written here, a, 255. Second value is here B. So 7 10 is written here, 7 10 and 1, and 10 2 and 2. So this is the third one. So all the 3 points are right here. So if you have more than 3 points or 4.5.6 points, so you have to be right all the points in this manner in a column wise. And then next, whenever you are going to be multiply between these two matrix, so after multiplication you get the new value that is called A dash, this is B dash, and this is C dash. So this is the new positions of the value of A, B and C after scaling. So you can whenever you are you just draw this particular vertex, a new vertex, so you can see that the effect of the scaling, it will be increases. So this is a simple numerical problem is there, has been going to solve here. So now come to the next point. What is the problem of this particular operation? If you are apply the scaling operation, then what will be the problem? In the next video you can see that. So actually one kind of problem is going to be arise always in a scaling. So what is the problem? Just under that understand by this figure. So suppose here is a one figure is given here, 1 1 and 2 2. This is the coordinate is there. So by according to this or based on this coordinate values or vertices values, we have just draw a rectangles. So after drawing that rectangles and apply the scaling factor, so here is the scaling factor is there, sx is equal to 2 and sy is equal to 2. So it means that this figure or object is going to be extended or expanded in x direction as well as y direction equally. So the box size will be going to be large according to this right now the whatever the value is given here or shown here, based on that you have decided that this will be happen in that form. So now come to the point, if you see that, so you can see that this is the large, so this box is going to be enlarged here, so double the size. But one effect is there, you can minutely observe that this point is going to be shifted here. So here, so you can see that this is the main point, so you can see that this is the reference point, so means that the point will be here, so that point must be fixed, but that is moving. So in that case we conclude that in case of scaling, so here is the point, you can see that that point is going to be shifted here. So that is the main problem. So what is the main problem? You can see here. So the problem is from the above figure, not only the object side is changed, definitely scaling have their own characteristics, means enlarge or decrease the size of that particular object. So object is going to be changed because we have applied the upscaling factor, so changed, but it also moved, which is undesirable. So this is the main problems. The object is going to be change, object shape is going to be changed, as well as the object position is also be going to be changed, so which is not so. If the object position is going to be changed, means that translation also be applied or also happens, so which is not allowed, because we are going to perform the scaling. So why the translation is going to be applied here, happened here, so which is not allowed. So this is known as an undesirable effect. So how to sustain or how to prevent this undesirable events? So here is the next solution is given here. So for that we have to be decide a point that is known as a pivot point. So based on that point you have to be scale up or scale down the objects. So you need a reference point to prevent this kind of undesirable conditions. So how to prevent this kind of undesirable condition? By using to select a arbitrary scaling point. So whenever you have arbitrary scale point, suppose this is a point of px and py, so based on the value of px and py, so this arbitrary point can be anything. You can select any vertex to an fixed point or arbitrary point. You can select any other point outside the figure or inside the figure. You can select as an arbitrary point. You can select any kind of point as an arbitrary point. So based on that point, the figure is going to be enlarge or decrease. So whenever you have applied this to prevent the means that if you are applying this pivot point, means that you are going to be prevent the undesirable situation. So how it will be prevented? You have taken a pivot point based on the pivot points, you first apply the backward translate means apply the same value in a backward direction. So here you can see that translate the object so that the p will be coincide with the origin. So your main target is that point is going to be coincide with the origins, means that you shifted the point to the origin, so that the value will be 0 0. So how it will possible? It will be possible to the backward translation, means minus direction translations. So already I have explained the translation matrix. So in that translation matrix, the translation factor will be writing your translation factor with minus sign, so that will be happen. So what is tx and ty? You can see that tx is equal to px and ty is equal to py. That's all, nothing else. And then scaling will be performed, because basic operation of scaling is based on the origin. So one point means reference point is going to be transfer the origin, then you have applied the scaling, so which will affect the other remaining points except that pivot point. Scaling will be performed based on that, same as I have already previously explained one numericals about the scaling. So you have applied that process or that approach to solve the scaling operation, and then again forward translation. Whatever the values you have used for backward translation, same values is used for forward translation. Without minus sign, directly apply the plus tx and plus ty. So this three sequence of operation will be performed one by one. So first you perform with point matrix backward translation, and then scaling, and then forward. So how it can be? So you can see that in a figure, very basic figure is given here. So you are going to transfer this point, that is known as a pivot point, to the origin. So you can see that here is an origin. The point is going to be transferred here, and then a translation is there, and then scaling will be performed based on this point. You are enlarging the value, so means you are enlarging the value in all the directions. So you can see that various directions is there, so just double the size of that particular, and then after that this point is going to be shifted again the previous position, that is the exact new position is there. So you just move that position, enlarge that position, enlarge the object, and then move to the remaining, means last previous position is there. So this is the process of three-step process to solve this undesirable conditions. So one numerical is there, so here simple figure is there. One interesting thing is there, one more example is given here. So whenever you are going to apply, means this is your pivot point, so shifted this pivot point to the origin here, you can shift here, and then this pivot point is here, you can see that. And based on this pivot point, now you are going to be apply the scaling factor in all the three vertices, means this one, and this one. In these three vertices, you have applied the scaling operation, and then again shifted this particular point to the previous position. So you can see that the object is going to be enlarged or decreased. So here the object is going to be decreased definitely. So whatever the scaling factor is, simple example there. So your pivot point is xf and yf. So this is the sequence of operations. You can see that from right to left, that is going to be multiplied. So whenever you are multiplied, so you have this resultant matrix. So either you can use these three steps of operations or multiplication, or you can use directly this matrix to apply to the point matrix. So whatever you want, you have to be remember this particular matrix or sequence of matrix or matrix operation you can perform. So this is the simple thing is given here. So either you can use this right side formula, right side matrix, or this three steps of matrix multiplication. So here is in some example is given. So in this example, you can see that our reference point is A. You just remember that our reference point is A, means mine px is equal to 2 and py is equal to 5. So you have to be apply this operation. So what will be the operation? First one is called backward translation. So you can see that this is the minus tx, this is minus ty applied, and this backward translation will be applied here. So directly applied to the point. So after the resultant, that will be applied matrix multiplication. Here the scaling factor is sx is equal to 2, sy is equal to 2. So matrix will be there, and then after that the again forward translation with the value of 2 and 5 will be applied. You can see that 2 and 5, 2 and 2 matrix, and this backward translation, and applied on the three points are there, that is A, that is B, that is C. So in the 3 points, first of all we applied the backward translation, and then the resultant will be multiplied by here, and then the resultant will be multiplied by the forward translation. So after that you get this result. So this is the final result, and you can see that A dash, B dash and C dash. So my friends and my dear students, you have understand that very well, how the undesirable condition can be prevent and how the scaling will be performed. It's the same, it's a very easy operations is there. You just remember the matrix multiplication approach and apply this approach from right to left direction. So you always remember that the first matrix towards the right is from the right to left. The first matrix will be the point matrix, second matrix will be the remaining whatever matrix you have decided, that will be applicable. So if you use a pivot point operations, so you need a three different matrix, that is called backward translation matrix. One is there, then scaling matrix, and then again the forward translation matrix. So all these operations is given to the final results. So dear students, you have understand that how the operation will be performed in scaling matrix. So if you like this video or understand the concept very well, so definitely you share with your friends, and don't forget to subscribe. So once again, thank you very much for this video.